So today's topic is counter. I think 3-bit counter will be enough. If I explain the 3-bit counter, then you will definitely make any type of counter. Before start coding, I want to describe some terms. First of all, what is counter? What counter is counter. It will count something. What count something? If you give its clock, it will increase by 1. If you give its clock, it will increase by 1. So just remind it and just take it in your brain. Then I just tell you that there are broadly two type of counters. One is asynchronous, second is synchronous. In in the case of asynchronous counter, I give one single clock and it will do its work. It will do its work. The mechanism of the in depth I will not cover here. You can go and watch a specific video theory part of a counter. I just tell you what we have need to hear. We have need to hear to code. Okay. Second, so what I tell you, a clock. If you give a clock in the mechanism, it will increase by 1. Increase by 1. Now we will customize the counter in such a way that will act as the up counter and down counter. Now what is up counter and what is down counter? The up counter refers that if you do trigger give a clock, then it will increase by 1 increase by 1. If you do clock, it will decrease by 1. If decrease by 1, it is down counter. It is increase by 1, it is up counter. Okay, clear. So counter, what is synchronous, what is asynchronous, you can go and see any video. You get then synchronous counter, there will be one clock associated with the whole mechanism, whole circuit, counter circuit, one clock, then up counter, then down counter. So it will make such a mechanism. Suppose just think about a switch. There is a switch. If I on the switch, then it is works as a up counter. It is down the switch, then it will works as a down counter. Just like that. Just think about it. Next, we have to consider a reset pin. What is reset pin? Reset pins refers that if you on the reset pin, then it means you whatever the value the counter now holds, means suppose we count first of all it counts 0. Suppose it counts 0, then 1, then 2, then 3. Now you want that the after that it will count no more and it will go back to 0. How you can do this? You have the reset pin. যেই আমি রিসেট পিনটা অন করব, সঙ্গে সঙ্গে এই এর বাকি যেগুলো আছে সেগুলো আর ইয়ে করবে না, কাউন্ট করবে না। ও সঙ্গে সঙ্গে ওর ইনিশিয়াল স্টেট 0-তে ফিরে যাবে। মিনস দিস ইজ কল্ড রিসেট পিন। সো দিস ইজ আর ব্রড টার্মস দ্যাট উই নিড ফর কোডিং পার্ট। So let's start the coding now. Coding part. So what will do? First of all, module name counter. Let's check take the pin. So what I just tell you. So you have to need a reset pin. So reset 1. Then you have a pin, a switch which will act as a up and down. If you on the switch, then it will act as a up. It will down the switch, then it will act as a down. So when a switch the direction, it will direct to the positive direction or it will negative direction, means up and down. Okay, so direction dir. It will once more thing is clock, very crucial, clock. And at last the output counter. So count counter, it will output. Now do think what will be your output. The output your should be a 3-digit number na. If you do it 3-digit, then you have to take a vector of it. You are not, you have to take a vector of it, means array type. So change it to the array. Why I am telling you a 3-bit counter? What is mean of 3-bit counter? 3-bit counter means it can count 0 to 7. So in the 3-bit configuration, you can write 0 as a 000 and 7 as 111. And just like that, if you give the clock, then it will 000. Then after the giving clock, it will 001. After the giving clock, it will 010. After the giving clock, it will 011, and so on, just like that. Yes or not? So the count should be vector type. 0 0 0. How can I store three variable in the one single variable? Three digit in the single variable? You can't. You have to take an array. Vector. Nice. Now next let's take a state variable which will initial in the code it will just do the up down the main part. Okay, signal state. Okay, state. Now look closely and what I will tell you. Okay, what is the data type of the state variable? I intentionally take it as a single number, a single string type number. How you can define it? Using unsigned. Remember unsigned. Okay, unsigned. How many digit in the unsigned in the number? 3, because it is 3-bit counter, so 2 down to 0. Okay, nice. The signal state unsigned 2 down to 0, and initially set it as 0 0 0. So means initially the my state is at 0 0 0 condition. So do you understand what it will do? I take a state variable like an unsigned integer types variable which have the 3-bit 3 to 0, and when I do state as an output, then it will I typecast the unsigned to the state like std logic type and give as output. মানে আমি বলতে চাইছি যে এখানে স্টেট ভেরিয়েবল হচ্ছে, এটাকে আমি একটা আনসাইন ভেরিয়েবল ধরে নিচ্ছি। আনসাইন ভেরিয়েবল ধরলে আমার কি সুবিধা হচ্ছে, তাহলে আমাকে বারে বারে ওই ব্র্যাকেট ইউজ করতে হবে না, মানে ইন্ডেক্সিং করতে হবে না। আমি যদি ভেক্টর ইউজ করি, ইফ আই ইউজ দ্য ভেক্টর দেন আই হ্যাভ টু ইউজ দ্য indexing each variable I would use the indexing part, indexing bracket use the bracket. But if I use the unsigned, then I can treat it as a number. It's a multi-digit number, multi-bit number, more specifically multi-bit number, and I can do operation like plus, minus, and any operations I can and do in unsigned number. So I take an unsigned in the initial part, in the transition part. When my work is done, I am just give the output, then I will convert in the vector type, the counter type, and vector type can be act as output. So now do remember that if you use unsigned, you have to add variable, a library which is std means that is std numeric std numeric. I see numeric underscore std, yes, numeric underscore std, yes. All the libraries you were added in your function, in your code. Okay, now do the logic part. Now you have to use the if else. Why if else? Why if else? If the direction is 1, then you have to go increasing. You have to, if the direction is down, then you have to like decrease. You have to 0, then you have to decrease it. So if and else. So begin the process. To use the if else, you have to begin the process. In the process, you have to give all the input. So all input variables in the input pins. Reset. Nice. Clock. Reset clock and direction. Nice. Done. Begin. Process will be begin. Now just do now just think about it. What it will do when reset is 1. If reset is 1, then whatever the value of state, it will turns into 0 0 0. So then check, then write if your reset is what 0 no 1, if reset is 1 means on, reset is on, then what it will do, the state will be your 0 0 0, whatever the value of state, I don't care, just it will turn into 0 0 0, it will reset it. means it will go from the previous initial state. Okay, else 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 reset is not 0, then you have to check the user want to go ahead or go backward. Means it will user try to say go for increasing direct increasing or decreasing. So else if direction is equal to 1 means the user want to increase the value, then state will replace with state plus 1. Is it so? Yes. Is it? Else 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 you know, else you 200% know the direction will be 0. There are two possibilities, either 0 or 1. So if you the direction is 1, then you will do plus 1. If else part, in the else you have to just state will minus 1. Okay, now here it is okay, but one thing that you have to remember, that why is the clock. You do the whole thing whenever you encounter a clock. In the previous video I do to clear the how the clock is work. Here the same concept. If you see a rising edge of the clock, what is rising edge? Please do the previous video SR flip flop. Okay, na? If I do the SR flip flop, then you will understand the what is clock mechanism here. Okay, I do understand. I do clear the what is how the clock mechanism is working. Okay, so if the it is rising edge means you encounter a positive edge triggering, encounter, then you will do all the things, either you will do nothing. So if you see a rising edge of the clock, then only you do all the things, either don't do anything. So just for defining, okay, nice. Airport. Now you have to end all the if. Here is end if, another end if, okay. This is for this, এটা for এটা, এটার জন্য একটা if, end if, nice. Last প্রসেসের জন্য process end process. তাহলে আমি এখানে শেষ হয়ে গেল. My work is done. Whatever, if you encounter a clock rising edge, then you will go, you check, is it reset? If the reset piece is 1, if reset piece is 1, then it will be 0 0 0. If reset piece is not 1, then go for else part, then check if direction is 1 or 0. If 1, then go forward direction. If it is 0, then negative direction. End process. So at the end, after doing this whole mechanism, after you get its value of state, and it will be your output, which is count. But as a output, when you showing the output, you have to convert it into STD logic vector type. Why so? But unsigned number, you can't show the unsigned number as a output. You have to convert it into vector type. And now you can also ask me, so why are you do just take the unsigned number? Because I told you, if I do consider the unsigned number as a numeric unsigned number, I can do the operations. If okay, do this operation, but if I not took as an unsigned number as a vector type, then it will messy na. You have to plus each and every bit of the number. Means you have to you will do the plus operation is for every bitwise plus. You have to use bitwise plus. But here you have the very easy na. So I use this unsigned number. I hope This is clear why I use the unsigned instead of just taking the vector. So my work is done, then I just the value unity count will be, the value of count will be, convert it means typecast it, std logic vector type. Okay, vector type your state variable state, state, nice. Okay, so this is the your whole counter. I think you understand what is reset pin do, what is direction pin do, what is clock pin do. Clock pin, I also told you that if you want to know in-depth counter, then please see the theoretical video. Here you can see the counter is made up of some T flip flop or JK flip flops. Okay, in one condition, JK flip flop or T flip flop, where it will toggle each step whenever it get a clock. But in whole mechanism, there will be only one clock. On the whole mechanism, only one clock is there. One clock is there. So if I do the broad picture, so whatever the mechanism will do inside, I don't care. I see that there is a clock which will input which is there. So clock, a direction pin that will tell the circuit that go increase or the back decrease, or a one is reset to whenever you want to reset it. Nice. And a counter which will act as output. Now what is now see what is unsigned. Why take I unsigned? I can do the plus minus operations here, and is very easy to handle. And you have to, if you do output as a unsigned, then you have to std output as a in another vector type, then you have to convert it into the std logic type again. Okay, I think it is clear. Then check it for synthesizing. Very sorry, here will be IEEE, just I missed it. IEEE dot. You know na, IEEE dot numerical right std na. So just I think now it is okay. See here also saying some errors. In fifth line number 15, there will be something missing. Acha, semicolon missing. Next, let's also check for Control S. Save it once more and check. Specify the upper bound and lower bound. As it is a 3-bit counter, then it will be 2 down to 0 na. 0 na. The 2-bit counter, a 3-bit counter. So the how many bits are there? 3 bit. Just 0, 1, 2, 3 bits. Now check for another check. See. হয়ে গেছে কাউন্টার, এটার আরডিএল ভিতর দেখে লাভ নেই, বোঝা যাবে নেক্সট এটা, ঠিক আছে। আর হয়ে গেল, এবারে আমরা ইয়ে দিয়ে যাই। এটা হলো কোড, একদম ঠিকঠাক আছে সব কিছু। I hope that you will understand what this means. The test bench now name will be test. Whatever you want to do, to take it. So clear me first of all, clear this mess. Next, clear this mess. Okay, now see in the previous SR flip flop, I cleared that how the here the clock mechanism is work. I need this clock mechanism. I need this clock mechanism. So here also we will not remove this. Okay, here you can use that instead of 10 you can use the 100 nanosecond. Why 100 nanosecond? It will show that each clock is in different very much in distance, so it will looks good on something. Now you can just here, I think yes, here you can just modify this. Here the signal in the direction will be as a 0, means it will decreasing. So by default you can use it as a 1, means it will by default it will 1. Okay, the reset pin also, reset pin means it is 0 means, see, okay na, 0 means 0, so it will not reset, it will not reset at all. Not make any sense, but you can. Okay, now see, I just delete it. Why? I use this clock period, the clock time period, this period, clock period into 10, means what it will refers when after the, this means 100, this means 100 into 10 means After 100 nanosecond I give another clock. After 100 nanosecond I give another clock. How much times I give? How much time I give? 10 times, just into 10. So I just use this for instead of that hard coded, okay na, predefined. So it will more convenient na. Now I just convert it to 10. You can use 10. I use 8. Why I use it? You can see, you can understood that if the counter is 0, if the counter is 3 bit, then it can count 0 to 7. So 0 to 7 there are 8 numbers. 0 to 7 there are 8 numbers, means after the 8th cycle, whenever you give another clock, suppose ninth clock, then it will do back to the again 0, and after again 0, and after the 10th clock it will 1, after the 11th clock it will the 2, and just go on the cycle through the whole loop, okay now. If I consider the direction is upward, and also for the previous case, if it is as a 0 0 0, if you give a 1 clock and direction is 0, direction is 0 means backward direction, then it will go to the 1 1 1 means 7, and again 1, again the clock, give the clock, then it will 1 1 0 means 6, then again clock it 5, and it will go this the loop. Consider this loop, okay now. So check. Suppose reset finish, your reset pin is 0, okay na? Means you do not reset it, and direction is your, suppose first, in the first case I do consider 1, okay. Let's check it, what it will do, or what it will do, okay na? So save it, and another mistake here, it will in the code na. Check it another again, try it again. See, that is, now check, is it working or not? See, suppose the reset pin is 0, so no reset. Direction is 1, means upward. Clock is 0, clock is 0. Here, see, clock is 0, then 0 0 0. Nice. Now, see, clock is 1. Positive is triggered. One clock is there, so it will changes to 1. Counter will be plus plus, means counter is there. Then see how much. Here, here, and till here, এই পর্যন্ত পুরোটা একটা ক্লক ছিল। আমি কি বলেছি, পজিটিভ এজ ট্রিগার, মানে এই পার্টটুকু আমাদের ক্লক হিসেবে কাজ করবে, এই পার্টটুকু ক্লক হিসেবে কাজ করবে, এখান থেকে শুরু করে এই পর্যন্ত পুরোটা একটাই কোনো কোনো ক্লক পাইনি, বেসিক্যালি কোনো ক্লক পাইনি, সেখানে পুরোটা এখান থেকে শুরু করে এই পর্যন্ত 1 অবধি আছে। যেই আবার সেকেন্ড ক্লক পেয়েছে, সঙ্গে সঙ্গে 1 0 1 0 হয়ে গেছে। আবার এখান থেকে শুরু করে পুরো এই পর্যন্ত আবার কোনো ক্লক পাইনি, যে কারণে এটা রয়েছে, যে এখানে এসে আবার ক্লক পেয়েছে, সেখানে কাউন্ট প্লাস প্লাস করে 0 1 1 হয়ে গেছে। এরকম ভাবে পুরো জিনিসটা শেষ পর্যন্ত কাউন্ট করেছে। অ্যান্ড if I do go last, and at the end, see, this is the 8th number clock. This is the 8th number clock. After 8th number clock, it will again goes to 0 0 0, 0 0 1, and so on. Just literally look through, just like that. Now check for the another case for when the direction is 0, okay na? So decreasing condition, okay. When the decreasing, the direction will be 0. So save it, and sorry, first of all I have to wait, stop. First of all, check the syntax. See here, what is doing? See, first of all, 0. Whenever they give a clock, it will turn into the 1 1 1, because 1 is decreases. If you do minus 0 0 0, it will by 1 it will gives 1 1 1 1 1, and 1 bit will be ignored, because the bit is, total bit is 3, okay na? 1 1 1, then 1 1 0 1 1 0 0, and at the end of the day, it will change, it will first 1 1 1, and then 0 0 0, then again 1 1 1 1 0 0, সেভাবে চলবে। সেম ক্লক মেকানিজম সেম ভাবে চলছে, যে এই অবধি কোনো ক্লক নেই, যেই একটা ক্লক পাচ্ছে সঙ্গে সঙ্গে 1, এই ক্লকটা কন্টিনিউ করছে কত অবধি, এই পর্যন্ত। এখানে এসে নতুন ক্লক পাচ্ছে, আবার এখানে একটা 1 1 1 বদলাচ্ছে, আবার এই ক্লকটা কন্টিনিউ করছে এই পর্যন্ত, এখানে একটা নতুন ক্লক পাচ্ছে, সেখানে এসে আর একটা হলো। just this is like that. So okay, nice.